Hey guys, so in this lesson I'm going to show you how we can take that vertex form that we were working on in the last lesson and turn it into what's known as the standard form so we can learn a little bit more about different parts of the quadratic or the parabola. So before we can do that, we kind of have to understand how to do what's called multiplying binomials, and that's where you take two terms that have two different terms like this one and multiply it by another one. So what's going to happen is you can use this method that's called FOIL, where the first thing you do is multiply the first terms. And so that's where you multiply the first term in this one by the first term in that one. So x times x gives us x squared. The O part says multiply the outside terms. So we're going to multiply this one that's on the outside with the other one on the outside. So the 5 that's on the outside. So x times 5. X times positive 5 gives us a positive 5x. I stands for inside. So we're going to multiply the inside terms. So that would be this one and this one. So we're going to multiply 4 times x. Positive 4 times x is plus 4x. And then the L stands for the last terms. So the two last terms in each of the brackets. So we're going to do 4 times 5. Positive 4 times positive 5 is positive 20. Now the last thing you're going to do is collect the like terms. Like terms are things that look the same. And in this case, the 5x looks similar to the 4x. So those two we can add together. So in this case, we'll get x squared. 5x plus 4x is 9x's, and then plus 20. So there you have it all simplified. All the terms are different, and we can't do anything else with it. And that is it. It's done. There is another method to do, which is called like the box method. And that's where you take, this came from the x plus 4. So I just took the first term and put it there in here. And I took the second term along with its sign. It was a plus 4, so I made the plus 4 go here. And then this one came from the x plus 5. So the x and the plus 5 here. And so what you're going to do is you try to multiply each two and sort of fill in the box. So x times x is x squared. X times positive 4 is positive 4x. Positive 5 times x, positive 5x. And positive 5 and positive 4 is positive 20. Now, really easily, you can see that here are like terms. They look the same. So we're going to add them together to make plus 9x. And then you can just take each of your things and put it together. X squared plus 9x plus 20. Notice we got the same answer. We just did it a little bit differently. You can just ignore this section. I sort of talked about like terms, but if you want to know more about them, they just have to have the same variable and same exponent. Just like 2x plus 3x, we can add those together. 4y3 and 5y3, we could combine them and add them together. So be careful. If they don't look the same, you can't put them together. Let's do another example. This one's a little bit different because it's got some negative signs in there. So be careful when you are using different signs that this negative sign is actually attached to that negative 8 or that 8, and the plus is attached to that 7. So when we actually do it, x times x is x squared. X times negative x for our outside. The negative stays with that 8. So it's negative 8x plus 7 times x. So plus 7x. And plus 7 times negative 8. Negative and a positive makes a negative. So it becomes negative 56. Okay, and then we will combine those like terms as well. X squared. Negative 8 plus 7 is a negative 1x minus 56. Now you don't have to write the negative 1. It's enough to just write it like this. It's just if there's nothing there, it's implied that there's a 1 in front of it. So now the question is, okay, that's cool, Jen, but how is this connected to quadratics and why do I need to do this? So what happens is this gives us a chance to take our vertex form, which we've already looked at, that looks like this, where we're able to find the vertex, which is at HK, and change it into a form that looks like this. Ax squared plus bx plus c, where a, b, and c are all just constants or numbers. And in this case, this is our y-intercept. So the reason we would want to change our vertex form into standard form is so that we could easily find the y-intercept. In this case, we know the vertex from the vertex form, and in the standard form, we know the y-intercept. So it helps us answer some questions, which we'll see in the later lesson. But let's do an example. I'm going to change the equation into standard form. So right now, it's in vertex form. And just on a side note, like you could easily find our vertex from this with our HK. H in this case is positive 4 and positive 6. So easily we can find that from there. Let's change it into standard form. And we're going to start by this squared here. Tells us that we're going to do x minus 4 times x minus 4. So if you actually write that out, you get x minus 4 plus 6. Now this here looks just like what we were doing on the previous page, and so we'll just multiply them out. So, but you're going to leave the 2 and the 6 for now. We don't need to worry about them. So I'm just going to multiply x times x is x squared minus 4x minus 4x, and negative 4. Negative 4 gives me a positive 16. And we'll just leave that 6 alone as well. Collect our like terms. So sort of clean it up a bit. That becomes negative 8x plus 16. And we've got that 6 on the outside. Before we can deal with that 6 on the outside, this 2 is in front. And what you're going to do is multiply it by every single term that's in the bracket. So it becomes 2x squared, 2 times negative 8, negative 16x, and 2 times 16 gives us positive 32. And now the 6 is on the end. Now that we've gotten rid of the brackets, we can combine those like terms. 2x squared minus 16x, and then 32 plus 6 gives us 38. So if we needed to graph this, right away we now have 2 points because this says our y-intercept is at 0 and 38. So we have our vertex 4 and 6 and our y-intercept 0 and 38. So you could easily try to start to graph that by plotting 4 and 6 which is right here, and 0 and 38, which is way up here. Way up here. It's not really to scale, but then you could easily start to graph it, which is really helpful. And it also answers a couple questions in terms of how high was something when it was dropped, or where did something start from when they jumped off the ledge. Questions like that. We'll see that later when we do some more different real world problems. But for now, just be aware of how to change that vertex form into standard form, and then the standard form gives you the y-intercept. Okay, have fun, guys.